Hi, and welcome to the second screencast documenting the work I'm doing on my shader development tool. And this time I'm going to show how I manage shaders and uniforms using state inheritance. Now when I talk about state inheritance, what I mean is the ability of a scene graph to pass 3D state on from a parent node to its children. So for example, if I wanted to apply a shader to the 27 cows that make up the matrix we have on screen here, I could apply the shader in the required uniforms 27 times to each individual cow, or I could apply the shader in uniforms once to the root node of my scene graph and let state inheritance do the work. So that's what we're going to do, but before I get into that, I want to talk about the scene graph that defines this matrix. The scene graph has a root node which encapsulates everything. Everything's a child of the root node. But under the root node are three child nodes which divide our matrix into three vertically aligned planes or arrays of 9 cows each. Then each array is divided into 3 horizontal rows, and then of course each row is divided into 3 cows. So anyway, our scene graph has a hierarchy of 4 levels: the root level, the array level, the row level, and then of course the cow model level. So I want to apply a shader to my entire scene of 27 cows. So to do that I need to have my root node selected, and I do. And the shader I'm going to apply is a cartoon shader, which is really just a simplified lighting model. And my cartoon shader requires one uniform, a color uniform, which defines the color of the models that we're shading. Now my color uniform is a 3-component vector defining the red, green, and blue values. We're going to give it 1 for red, 0 for green, and 0 for blue, which makes this a red color uniform. And then we're going to add our shader, our cartoon shader, which I've named cow. And now you can see I have a matrix of 27 red cartoon cows. But just as state is intended to be inherited in a scene graph, it's also meant to be broken. For example, let's select the left array, and let's add a uniform to the left array called color, just as we did at the root. Only this time let's give it 0 for red, 0 for green, and 1 for blue. This will be a blue color uniform. As soon as we do, we see the left-hand array of 9 cows suddenly turns entirely blue. And of course what's happening is that the shader state, the shader that I applied at the root level, is still being inherited by all 27 cows. All 27 cows are shaded by the cartoon shader. But when the scene graph gets to the left-hand array, it sees that there is a color uniform defined at that array node, and it overrides the color uniform defined at the root node. And so the left-hand array is colored blue, whereas the right and middle arrays are still colored red, because they have nothing defined below the root node. Anyway, just as we can override the uniform state in the scene graph, we can also override the shader state. So let's select the right array, and let's add a shader to that. And this is a fog shader. And as soon as we do, we see that our right array becomes an array of 9 foggy red cows. So again, what's happening is that state is inherited in a scene graph from parent to child, except where the same state already exists at the child node. In the case of our left-hand array, the uniform state is overrode because we already have a state defined at the array level, and in the right-hand array, the shader state is overrode because we have a shader defined at the right-hand array level. But let's say we want to revert the middle row of our right-hand array from the fog shader state to the original cartoon shader state. Well, state inheritance only works in one direction. It either inherits or it overrides. There is no way to actually revert state. So if we want to bring back that cartoon shader effect, we need to select the middle row of our right array, and we need to add the cartoon shader that we added at the root node. And as soon as we do that, we see the middle row of our right array becomes cartoon cows once again. Well, that's about all I had for this screencast, but in the next screencast I'm going to take what I demonstrated here and apply it to something a little less trivial. In the next screencast I'm going to get into scene lighting and how I manage scene lighting in my development tool using scene inheritance and the scene graph hierarchy.